Hi, I am Mrs. Jardine, and so I'm going to go over succession today, but before I do that, I'm going to go over a couple terms that are in your section of your chapter. So the first one is a limiting factor. If I'm going to say, I'll put a limit on the number of cookies that you can eat, what do you think that means? That you can have 87 or you can have like one? I'm going to put a limit. I'm going to prevent you from having a lot, right? So a limiting factor is any biotic. If you remember the last PowerPoint, biotic, prefix bio means living. So a biotic factor is a living factor, like a fish or a tree. Abiotic, you put the letter A in front of the word, it means the opposite. So biotic means living. What do you think abiotic means? Non-living. Very good. So a limiting factor is any biotic or abiotic factor that restricts the number of species. So it means it makes it go down. So if there's like 100 deer in the forest, hunters come by and kill 60 of them. That would be a limiting factor. It's causing the population to go down. So competition, that would be competition between each other. Predation is what that would be. A disease can be a limiting factor. A huge tornado could be a limiting factor. So because it could be living, predation, competition, any of that, or it could be abiotic, so like a tornado. Other examples are high elevations. That's going to determine what can live there. It's going to keep the population down. Low temperatures, if it could cause them to freeze, keep the population down. Strong winds, thin soil, any of those things can keep the population down. The other term I wanted to go over is tolerance. Tolerance is the ability of an organism to withstand fluctuations. So like high temps, low temps, high temps, low temps. That would be huge fluctuations in biotic and abiotic factors. So that would temperature be abiotic or biotic? Abiotic, very good. Versus, so like temperature of the water, for example. If you've ever fished in a river or been to a river, rivers are usually cooler than lakes, right? So organisms that live in rivers are adapted to that short temperature change. So like trout, for example, can live in rivers. They like it really cool, specific temperature change, okay? These trout probably wouldn't be successful in a really, really lake that gets really warm and really dirty. Bullheads, I don't know if you know what bullheads are, but they're this species of fish that are known to live in dirty, dingy lakes. Like they have a very wide tolerance change. So trout have a very narrow tolerance change. They're going to die off if it gets too hot. If the water gets really dirty and mucky and very little oxygen, they're going to die. Okay. Whereas bullheads are like, whatever, I can live anywhere because I'm amazing. And so they can live in a very wide range. So they can live when there's very little oxygen. They can live when it's dirty. They can live when it's warmer. They have a very high tolerance. Okay. So like I'm from Minnesota. My husband's from Wisconsin. When we first met, when we grew up, we went fishing all the time. And we would catch bullheads, like, cause there was like no limit, I don't think, or like the limit was like 100 or something, a day. So we just catch bullheads. And then we'd go home and eat them. And when I met him and we were talking about fishing, we went fishing or something, and I was talking about bullheads, he goes, "You can't eat those." I go, "Yeah, you can. You roll them in flour and fry them in butter and eat them." He's like, "Nobody does that." And he thought I was lying. And I was like, "Yeah, because I'm going to lie about eating bullheads." Like, what the heck? So, long story, she didn't believe me. So then he goes and asks his uncle, and his uncle's like, "Yeah, you can eat bullheads." So apparently it's not like normal to eat them. Where I grew up in the middle of nowhere, we ate them, whatever. But I think the reason why is because they have such a high tolerance that they might not taste as good because they're living in the dirty, murky lakes and stuff. People probably think of them as dirty, gross tasting fish. So that's those two terms I wanted to go over. Okay, so now we're going to talk about succession. Succession is the natural changes in species replacements that take place in a community. So what does that mean? There's two types of succession. There is secondary succession and primary succession. Actually, we're going to go talk about those two first, and then we'll come back and talk about climax community. So primary succession, not that it happens first, because they both don't happen. Primary succession is where there's no soil. Like whatever happened took all the soil away. Okay. This doesn't look like that, but this is rock, because I Googled primary succession and this picture came from Wikipedia and it said that it was rock. So I hope that it is. So for example, you get a volcanic eruption. Okay. And then when the lava cools, it's rock. Or you get like, glaciers melting, and what's exposed is rock. Those would be examples of primary succession, because you have rock. It starts with rock, right? And then the first species to the area are called pioneer species. You remember pioneers back in the olden days, or the first settlers to go out west? They're called pioneers because they're the first ones. So pioneer species are the first species to basically live on that rock, and they're mosses or lichen. Lichen is a symbiotic relationship between algae and fungus. They both work together. One kind of get a place to live. One gives out carbon dioxide. The algae does. What else? Oh, the fungus gives out oxygen. Yeah, the algae takes in carbon dioxide because it's plant-like, does photosynthesis, and gives off oxygen. The fungus is heterotrophic, and then it gives off carbon dioxide, and then they live together. So they live mutualistically. They both benefit. And it is the first species, pioneer species, to come live on that rock. Have you ever been to a cemetery and you see, because it's the stones, and you see stuff growing on the ones from the 1800s that's lichen or moss or whatever. And so now these rocks that you can see it growing on here, that grows there. So then years and years and years go by, and then the lichen dies, and it starts to break up the rock at times, or it starts to make this like really fine soil. So then you might get a few weeds. So like years and years and years, hundreds of years, you had this lichen, this moss grow on this rock over and over and over and over, and then it dies, and then you might get a weed to grow in the dead decaying lichen and moss, whatever. So then you get, and eventually see how this is soil. A soil is made because over time, as that happens, hundreds of years. And then you get the first weeds to come. Okay. And then you get some grass to come. And then you get bushes to come. And then you get trees. And then all of a sudden you have a sustained community. So a climax community is like this community hasn't changed over many, many, many years. So I'm going to go back and show you that term. So climax community is a stable, mature community that undergoes little or no change. So here's pioneer species. Like, I don't really like this picture, but, this is secondary succession, that's why. But pioneer species is the first species to come to the area because it's the first one. So primary succession, there was zero soil, no soil, okay? None, no soil. That moss and lichen have to come, lichen mainly, not really moss. Moss needs it really moist. So, if the rock is really moist, then the moss will go live on it. But if there's no moisture, then it'd be lichen to come and grow on that area. And then over years and years and years and years, it takes to make the soil. Secondary succession, there is soil. So secondary succession, there's some type of disturbance. Obviously, in this picture, it can be forest fire, burns out everything. All you have left is the soil. It could be a mudslide. All you have left is the soil. It could be from deforestation. All you have left is the soil. Any of those things, farming, anything like that. And all you have left is a bare soil. And so then the first species to come is going to be, see here, all you have left is the soil. Then you're going to have the grasses and the weeds and things like that. And then the bushes will come, and then the trees. And then number 8 here, this is the climax community, stable, mature community with little to no change. So these are 2 different types of succession. I like to compare them like baking a cake. I'm sure you can buy cake mix for like $1 when it's on sale, and you have to add eggs, oil, and water. Okay, make it up, you get a cake, right? Or you can make a cake from scratch from a recipe book where you have to have flour and sugar and vanilla and eggs and all of the other things that you have to add. And then you mix it up and you put it in the oven and you get a cake. At the end, you both get a cake. At both of these successions, at the end of primary succession, you get a climax community at hundreds of years. At the end of secondary succession, you get a climax community. Which one would be like using cake from a box? Secondary, very good. Which one would be, so then the other one, making a cake from scratch, starting with all of these ingredients, would be like primary succession. Because making a cake from the box, you already started with the soil. Like the box of cake mix would be like the soil. Okay? So you already started with that, so it's a lot faster. So secondary succession to reach climax community is a lot faster than primary succession, because primary succession had no soil to start with. So weeds can't just come and grow and because the soil needs to help to stabilize them so they can grow taller and things like that. Primary succession doesn't have soil. Secondary succession does. So like the cake mix, if you start from scratch, if I said, ready, set, go, and you and your buddy Susie, one of you got to make it. Susie got to make it from a cake mix, and you had to make it from scratch. Susie would get hers in the oven faster. She has to add 3 things: 2 eggs, 1/3 cup of oil, and some water. Stir. You have to like get everything out, measure it, and all that stuff. So primary succession takes a lot more time because there's no soil. In secondary succession, there is soil. Any questions on the 2? right, let me know. I think that's the end. Yeah. I hope, yeah, let me know if you have questions.